Good day, learners. Welcome to today's mediation of trigonometry test, which was written on the 10th of October 2025. So I'm going to take you through the solutions. I know that I shared the Word document with you, but just to mediate whatever is in that document. Let me share the screen without wasting time. Okay. As I said, test will be about trigonometry. It was about trigonometry. My name is Pandimo. Now, the first question says, if sine 35 degrees equals to k, express each of the following in terms of k. So we know that unlike in the questions where you are given restrictions, so here angle we know it is 35 degrees, which is of course in the first quadrant. So then it will be 35, and obviously if it's 35 here, you can just write 55 here, so that when you are given 55, you don't have to do the reduction. So you already know the angle. Now, the first one says cos 55. What you do first, you draw the diagram, then find unknown in this case in terms of k. So remember, you're given that sine 35 is equals to k. We know that sine is opposite over hypotenuse, so then opposite in this case is k, hypotenuse is 1. Then you are calculating x. Then you apply Pythagoras to calculate x, then you find that x is equals to the square root of 1 minus k squared. So that is why now that you know x, we say what is cos 55? Remember, cos 55 is the same as sine 35. So it will still be a k. 1.2 tan 135. Remember, 135 is in the fourth quadrant, and tan in the fourth quadrant is negative. Then you first reduce it to be minus tan 35. If it's minus tan 35, we know that tan is opposite over adjacent. Then the opposite in this case will be your k, and then your adjacent is x, which we calculated in 1.1. Then it is which is 1, the square root of 1 minus k squared. So your answer will be minus k over root 1 minus k squared. It will be minus k over 1 minus root 1 minus k squared. And then 1.3. 1.3 can be done in two ways, since we know that one of our angles there is 55. We can just say sine 110 is sine is equals to sine 2 times 55, then it will be 2 sine 55 cos 55. So we know that sine 55 in this case will be 1 minus root 1 minus k squared, and then cos will be k. So we take, or you can reduce it to be sine 70, because we know that sine 110 is 180 minus 70 degrees, and we know that sine is in the second quadrant, and sine in the second quadrant is positive. Then, and when you change it to a double angle, it will be 2 sine 35 cos 35. Then sine 35, we know that is k, and then cos 35 will be 1 minus k squared. The next one is 1.4, sine minus 160. If you know that when you talk about the negative angles in trigonometry, you move clockwise. So if you move clockwise, minus 60, 160 is in the third quadrant, and we know that sine in the third quadrant is negative. So if you want it to change, you want to change it to 35. Remember, if you have 160, it's either you can say 180 minus 20 or 90 plus 70. So here we'll not go to for 20 because our angle that we want is 35. So you cannot deduce angle 35 from 20, but you can deduce it from 70 because it could be a double angle. Now minus cos 70. The reason why we say minus cos 70 because for us to get 70 you must use a co-function. It must be sine minus 90 degrees minus 70 degrees. Then we know that still in the third quadrant sine is negative, and then but because we used 90 it will be its co-function. Then it will be minus cos 70. So then cos 70 we know that is a double. Then it's either you can say cos squared minus cos squared 35 minus sine squared 35, or you can say 2 cos squared 35 minus 1, or you can say 1 minus 2 sine squared 35. They will give you the same answer. Remember, the expansion of cos is in 3 ways. So anyway, any one of that will give you the answer 2k squared minus 1. Now the second one is a Pythagoras type question again. We say if 12 tan theta minus 5 equals to 0, for theta is an element of 180 degrees and 360 degrees. So what you will do, first you'll make the tan the subject of the formula. If you have tan theta, then this will be 5 will go this side, will become positive. Then you have tan theta equals to 5 over 12. If tan theta is 5 over 12, then we know that tan is positive in the first quadrant and the third quadrant. But now it means second and third are out, because tan can only be positive in the first and the third quadrant. From there we check the restriction. Restriction says between 180 degrees and 360. It means the first quadrant falls off. It means we'll be left with only the third quadrant. We'll be left with only the third quadrant. If you're left with the third quadrant in this case, you let me just, I think, yeah, if you check this one is the one for this term in the third quadrant. Remember that you have tan equals to 5 over 12, but we know that in the third quadrant x cannot be negative and x cannot be positive and y cannot be positive. So it means x will be negative 5, y will be negative 12. But let me also bring it to your attention. It doesn't matter which quadrant you use, r will never be negative. But x and y can be negative depending on the position on this Cartesian plane. Same thing now you go to, it means when you check the correct quadrant, first you check the sign, from there you check the restriction, then you'll be left with only one quadrant. The other one which says 5 cos alpha plus 3 equals to 0. If we make cos alpha the subject of the formula, the cos alpha will be minus 3 over 5. If it's minus 3 over 5, you say, where is cos negative? Cos is negative in the second and the fourth quadrant. But let's check the restriction. Restriction is not always given, be given as another ratio, where sine alpha is greater than 0. Now, remember we said cos is negative in the second and third. But now we say where sine alpha is greater than 0. Anything that is greater than 0 is a positive. Now, we'll say between these two quadrants, where is sine positive? Sine is positive in the second quadrant. So it means the third quadrant is eliminated by the restriction which says sine alpha is greater than 0. Now, let's start with this one with alpha. So if for this one of alpha, we don't know r, we apply Pythagoras as we did. Apply the Pythagoras in this case. Then we are solving for r. Then we know that x squared here is minus 3. Then y squared is unknown. Then r is 5. No, here r is 5. Then when you calculate, then you make y subject of the formula. But since it's in the second quadrant, remember above the x-axis y is positive. So because the diagram here is above the x-axis, it means y will be positive. And also we look at this one of 10. What we don't know is r. We substitute x is minus 12, y is minus 5 equals to r squared. Then this will be 169. The square root of 169 is 13. And remember, as I said, tan can never be negative. Sorry, r can never be negative, I will say. It doesn't matter whether it's in the second quadrant or where. R can never be negative. Only x and y can be negative. Remember, on the left-hand side of the y-axis, x will be negative. Below the x-axis, y will be negative. But r can never be negative. Now, cos minus theta is in the fourth quadrant, and cos in the fourth quadrant is, then that will be cos theta. Remember, you use the cast rule to remember. If you don't want to forget, say all students take coffee. Others will say all science teachers are cool. So as long as it can make you to remember this cast rule. 2.2 cos theta plus alpha. Now we have two angles. It means now we are going to use these two diagrams because we have two angles, the one of alpha, the one of theta. So then we expand this as a compound angle. Then we have cos theta, cos alpha minus sin theta, sin alpha. So cos theta equals to negative 12 over 13. Cos alpha is equals to minus 3 over 5. And the minus, then you say minus. Yes, minus is not equal sign. And then you say minus, then you substitute and get the answer. But most importantly, you expand this compound angle. Then you get the answer. The answer will be 56 over 65. 2.3 sine squared 360 minus 2 alpha. I know that some learners will be tempted to say because sine is negative in the fourth quadrant, then the answer is negative sine squared 2 alpha. That will be wrong. Remember, if sine is negative in the fourth quadrant, then it's a square. You put the negative inside the brackets to show that this negative is part of the square. If you say minus sine squared 2 alpha, it will be like this negative is not part of this sine squared. So it must be inside the brackets. You say this will be minus sine 2 alpha all squared. Then this will be sine squared 2 alpha. And then even here, it's the double angle. You can't say when you expand it and say this is 2 sine squared alpha cos squared alpha. No, the square is for the whole thing. Then you put square outside the brackets. Then you change this into a double angle. It will be 2 sine alpha cos alpha. then you substitute the value, then get the answer. Now, number 3. In the diagram below, OQ is equals to 17 units and OP is equals to 15 units. The coordinates of P and Q are M and N, and K and 8, and then POQ equals to QOS, which is equals to alpha. Now, first calculate the numerical value of K. Of course, you'll just use Pythagoras in this case to find here. You know that your x is k, your y is 8 squared, your hypotenuse is 17. Then k will be 15. That's the first one. 3.2. Find the numerical values of m and n. Now, I want you to remember this. The angles of the arm is always measured from the origin in the anti-clockwise direction. It means now we can't say the angle of this arm, which is 15 units, is alpha. No, it's 2 alpha because the angle must be measured from the origin, from the x-axis. So it means the angle for this arm is 2 alpha. So because you don't measure the angle from one arm to the other. You measure the angle from the x-axis in an anti-clockwise direction. It means the angle for arm with 17 units is alpha, but the angle for the arm with this 15 units, OP, it will be 2 alpha because the angle is measured from the origin. Now, when you go to the second question, since now we are calculating, we want to calculate M and N, then we will say cos 2 alpha. We say cos 2 alpha because that arm there is 2 alpha. So it means now for M and N, you'll use them in the ratio of 2 alpha, not alpha. And for K, 17 and 8, you use them in 1 alpha. So therefore you first say, because you want to use both 2 alpha and alpha, you can use a double angle and expand it so that you'll have 2 alpha on one side and you have 1 alpha on the other side. We know that expansion of cos 2 alpha can be written in 3 ways. It can be cos squared alpha minus sin squared alpha, or it can be a 2 cos squared alpha minus 1, or it can be 1 minus 2 sin squared alpha. So, but now for this cos 2 alpha, because for this arm of 15 units, it means the values we substitute are m, n, and 15. So remember, cos is x over r. The x here is m, r is 15. But for the right hand side, because it's not 2 alpha, then you'll substitute the value of the first arm with 17 units, because the angle of the first arm with 17 units is 1 alpha. It's not 2 alpha. Then you substitute, then you cross multiply to get the answer. You can see, also we say, because m is in the third quadrant, then the answer will be negative 2415 over 289. You can also use the 1 minus 2 sin squared alpha. You can use cos squared alpha minus 1. You can even use the double angle of sine. You'll get the same answer. But now, double angle of sine, you are going to use it when you calculate n, because sine is y over r. Then y of this the arm with angle 2 alpha is n over 15. Then you substitute. But we use the double angles because we have 2 arms, one with 2 alpha, the other one with alpha. So if you can check, even if you can take these being fractions like this, square them, apply Pythagoras, you are still going to get the answer as 15 to show that all these values are correct. If you apply Pythagoras and then calculate, say, the m squared plus n squared, you are still going to get 15. 3.3, by using the diagram, the value of sine 3 alpha is. So since, again, we have 3 alpha here, but we don't have an arm with 3 alpha. So it means we are going to expand this 3 alpha into sine 2 alpha plus alpha, because the 2 arms have the 2 angles 2 alpha and alpha. So then when you expand it, then this will be 2 sine 2 alpha cos alpha plus cos 2 alpha sine 2 alpha sine alpha. Now since you have the values for the 2 arms, then you substitute. And when you substitute, then you get the answer as 8 over 17. Number 4, if f of x is equals to 2 cos x plus 2 root 3 cos sine x, find the maximum value of f. Now, when you find the maximum value of f, remember you can only find the maximum if you work this out to be one trigonometric ratio. Now here there are two. Then you say, what can you do? You say, you can make this to be a double angle of cos, because you can see that if you divide by 4, you'll have half, and half is cos 60. And then if you divide by 4 again here, 2 will cancel 2, we'll have to root 3 over 2, which is sine 60. By mere looking, you can see that if you can divide by, but remember, if you create something, you must counter what you created. Remember, you want to divide by 4 throughout, but because you have just taken 4 from somewhere, do it in such a way that it's like you did nothing, because 4 over 4 is still 1. So you want 4, but you divide by 4 and also multiply by 4. So it's like you did nothing, but the aim is to change this into one trigonometric ratio. So when you multiply by 4 and divide by 4, then 4 will be, this 4 of the numerator will be the common factor. Then 2 divided by 4 is half. 2 divided by 4 again is also half. So remember, 4 is a common factor in this case. So we know that cos 60 is half, and then sin 60 is root 3 over 2. So you can see that this is a format of the cos compound angle. So this will be 4 cos into 60 degrees minus x. Then you can see that now it's one trigonometric ratio. Then if it's a one trigonometric ratio, then we'll say the maximum value is 4. And remember, even if the answer here was negative, we'll say the maximum is 4. So remember, even if the graph start by going down, the maximum will always be this positive value. The maximum value will be the positive value, unless the graph undergoes a vertical shift. If it undergoes a vertical shift, then the maximum value can be negative. But here, there's no vertical shift. There's no vertical shift. Number 5. Given the question where you had to determine the reductions. Now, given f of x equals to this, first one, f of x equals to is like in a convergent question, you'll be required to simplify this expression. But now, because now consider the nature of the test that was written. So here I'll just say the f of x equals to, but the question will be simplified. So now when we reduce sine 360 minus x, 360 minus x is in the fourth quadrant, and sine in the fourth quadrant is negative. Then that is why it will be negative sine x. And Linus, I want to bring this to your attention that what I like about this question of reduction, I always say these are marks for free, because every reduction will be awarded marks. So meaning that even if you make mistake with other reductions, you'll get marks for every reduction that you'll get correct. So meaning that in this case, because you reduced 360 minus x, you'll get 1 mark. Here you reduced cos minus x, you'll get 1 mark. Here you reduced cos 180 minus x to be minus cos x, 1 mark for that. And then here you reduced cos 90 degrees minus x into sine x. Why is it positive? Because you used 90, then it will be a co-function. Here will be, you reduce sine 135 into minus tan 45 all squared. Remember, as I said, if it's a square and the answer is negative, the negative must be inside the brackets to show that it's part of that ratio. Minus 2, even here is 180 plus x, which is in the third quadrant, and then sine in the third quadrant is negative. But because it's a square, you put square this negative inside the brackets. So then you simplify, then you get the answer as negative tan 2x, which is one trig ratio. Now, 5.2, if it is further given that f of x is half, for x is an element of negative 90 degrees and 180, the values of x are, now see, remember, we simplified that in the first question, so we are not going to simplify again. You just say minus 2 tan 2x is equals to half. You divide both sides by negative, then it will be tan 2x is equals to minus half, and then if it's minus half, you'll say shift sign negative half, you get negative 26,57. Then remember our angle is 2x, then you divide throughout by x. But remember, the period of a tan graph is 180 degrees. So I know that those who are doing science to understand this phenomenon of the period, in science, when you talk about the waves, the period is time taken for by one complete vibration or a cycle or oscillation. So in this case, because if you look at the tan graph, it breaks between minus 90 and 90, which is the length of 180. Then that is why the period of tan is 180 degrees. But remember, k is an element of integers. K is not an element of real numbers, or k is an element of integers. It can be decimal, but it can be negative. Then if now you want the values, the specific solution, remember first you generalized it by saying k times 180 for k is an element of integers. So now, when you divide from there, if you want the specific solution, you play with k. Like for instance, one can ask a question and say, where do you start? By me looking, you can see that if you say k is minus 1, the answer you get will not be between the interval which was given. So if minus 1 is not working, then you go for 0. Remember, k is an integer. So then if you go for 0, 0 times 90, say 90, then it means the first value will be negative 13,28. Now, from 0 you go to 1. 1 times 90 is 90. 90 minus 13,28 is 76,72. Now, from there, you keep on going until the values you get are outside these two intervals. So in this case, 1, if k is 1, the x will be 76,72 degrees. Now we go, if k is 2, 2 times 90 is 180. 180 minus 13,28, then it will be 166,72. Then these are the values. You can see that if you say if k is 3, now it will be 270 minus that, then the answer will be outside the interval. Remember, in exam, you will not be penalized for not showing how you calculated, as long as the marker see this generalized equation. Now, and then you indicated that k is an element of integer. The marker will understand that you got your answers from your general solution. For x is an element of minus 90 and 90, the values of x for which f will be undefined. Remember, this can only be undefined if the denominator is a 0. So if you check, when we were simplifying this, our denominator will be 1 minus 2 sine squared x, which is cos 2x. It means this can only be undefined if the denominator equals to 0, which happens to be cos 2x in this case. So we say for this to be undefined, cos 2x should be equals to 0. The same thing, shift cos 0, then we get plus or minus 90. If you draw a cos graph, we know that the cos graph y will be 0 at 0. Y will be 0 at 90 and 270. So, but because now the 90, if we say plus or minus 90, 270 will be covered, because 360 minus 90 will be 270. So we'll say 2x is equals to plus or minus 90 degrees plus k times 360, where k is an element of integer. Remember, the period of cos and sine is 360 degrees. It's for 1 second. And then x will be plus or minus 45 degrees plus k times 180. So if now you want to generalize it, you want to find a specific solution between the given interval, it means x will just be between negative 45 and 45. So it will just be a. It can be 90, because if it's 90, then if it's 90, then it means the value there will be outside there, that interval. Now the answer will just be plus or minus 45, because now if you say k is 1 or minus 1, if k is 1, you say 180 minus 45, which is 135, and 135 falls outside the given interval. So it means x will just be plus or minus 45 degrees. Number 6, cos squared 43 minus sine squared 17 can be simplified as. Now, if you check this, you're given the two ratios, and in these two ratios, the angles are different. Now, you make the angle to be the same if you are given this kind of a question. Remember, the other one is cos 43, the other one is sin 17. So you can make angles to be the same, because 43 is 30 plus 13, and 17 is 30 minus 13. So it means we'll make angles to be the same from different angles. So it will be cos squared 30 plus 13, which is 43, minus sine squared 30 minus 13, which is 17. You made the angles to be the same from different angles. Then even in this case, you say square, to show that when you expand, you put square, because the square is for the whole thing. It's not only for 30, it's not only for 13, it's for everything. So when you expand it, then you say all squared. The same thing you do this side. So obviously you'll FOIL, then here after foiling, then you multiply every answer by negative. So if you multiply every answer in this case by negative, you get something like this. Then you simplify this, and you can see now here you take out half as a common factor, you remain with sine squared 13 minus sine squared cos squared 13 minus sine squared 13, and you can see that this is a double angle of cos. Then this will be half cos 2 times 13, which is half cos 26. Number 7, 4 sine theta cos cube theta is equals to 4 cos theta sine cube theta. Now, when you have an identity, what I can tell you is that identity can only be difficult if you don't start. See what you want to do. Start somewhere. Like here, what is the first? Don't worry about the answer when you start the identity. Check what you can do. Then, in the second step, you check the progress that you have made. Let's check here. 4 is a common factor. Sine is a common factor. Cos is a common factor. Then it means a common factor will be 4 sine theta cos theta. Then here will remain with cos squared. Here will remain with sine squared. Now, cos squared minus sine squared is cos 2 theta. And then here, we know that the double angle of sine is not 4 sine theta cos theta. That's why we say 2 times 2, so that this one will form a double angle of sine, and this other one will be the double angle of cos. Then you'll see this is also a double angle because it's still 2 theta, 2 theta. Then the answer will be sine 4 theta. Now, sine squared, and now you are given something here. Now we are given something here. Given that sine 2 cos squared theta plus 3 sine theta cos theta minus cos theta minus 6 sine theta equals to 0. The first question, find a general solution. Now, what you're going to do, you can see that this is a polynomial. If you have polynomial, we know that the first option will be to factorize this by grouping. So we group the first two, we group the last two, because they have a common factor. If you take out, in the first two, if you take out cos as a common factor, he'll remain with 2 cos theta. If you take cos as a common factor here, will remain with 3 sine theta. Then here, there's a common factor of -2. So you take -2 as a common factor, and you know that when you take negative as a common factor, all the terms will change signs. Then -4 divided by -2 is 2, -6 divided by -2 is 3. Then you see that you factorize by grouping, and we still have a common factor, which is 2 cos theta plus sine theta. Then when you take it out as a common factor, then here will remain with cos theta minus 2. Then here cos theta will be 2, then this is rejected, because cos and sine cannot be an improper fraction, because both adjacent and opposite can never be more than the hypotenuse. So that is why this value here is rejected. Now, again, when coming to this one, you know that if you have a cos and sine with same angles and same exponents, then you divide throughout by cos, so that you can make this to be one trig ratio. So when you divide by cos, sine, it will be 10. Cos divided by cos is 1. Then obviously you'll divide this side by 3, then you have tan theta equals to -2/3. So there is a shift tan -2/3. So when you generalize, it will be minus 33.69 plus k times 180 degrees. As I told you that the period of tan graph is 180, then where k is an element of integer. So unlike the previous one, here you stop here here in this step, because we don't want a specific solution, we want a general solution. Then this will be your final answer. 8.2, for theta is an element of -90 degrees, the values of theta are now you can see that here, if k is equals to 0, then your theta will be minus 33.69. And like I said, you check for you to know where to start. You play around with k to let k to be any integer, but you do it with reference to the given interval. So if we can say k in this case is -1, -1 times -180 is -180. -1 times 180 is -180, minus 33.69. It will be minus 213.69, which is outside this interval. So it means -2 does not work, but even -1 does not work. The first one that will work will be 0, because k is an integer. 0 times 180 is 180. Then the first value will be minus 33.69. After you tested 1, you go to or tested 0, you go to 1. 1 times 180 is 180. 180 minus 33.69 is 146.31. So when you find the specific solution, you just go to the general solution and play with k. Let k to be any integer, depending on the interval given. So if you check -2 is not working, then you go to -1. If -1 is not working, you go to 0. Even if -1 is working, the next one will check 0. After 0, you check 1, until all the values are falling within the given intervals. Number 9, the general solution of cos 2 theta plus cos theta equals to 0. Learners, I want you to remember this. Expansion of cos 2 theta can be in 3 ways. But now, every time when you check, you first check the middle one. If the middle one is a cos, you make it the cos one. You choose the one with 2 cos squared theta minus 1 because the middle one is cos. The main aim is to make the ratios to be the same. Then you factorize, then you get the answer. Then it's half and minus 1. Then when you generalize it, it's a shift cos theta will be half. Shift cos half will be 60. But remember, for cos we say plus or minus because cos is positive in the first and the fourth quadrant. And in the fourth quadrant, when you move clockwise, then it will be minus 60. Here, because we didn't talk about the specific solution, you stop here. Now, let's look at the number 10. Number 10, we still have a double angle of cos, but in the middle now, it's not cos, it's sine. Then you'll take the sine one, because in the middle you have sine. In the first one, you took the cos one, because in the middle you have cos. The second one, you say it's the sine one, because in the middle is a sine. Then from there, when you simplify and write this in a standard form, it will be 2 sine squared minus sine theta minus 3 equals to 0. Then you factorize, then you get the answer. Like I said, cos for sine and cos, the fraction cannot be improper because adjacent and opposite cannot be more than the hypotenuse. Then the only value that will be valid will be cos theta is equals to minus 1, and the cos can only be minus 1 at 180 plus and minus 180. Then this will be your general solution. This one you stop here because it's not a specific solution, it is a general solution. Number 11. In number 9, we change the double angle of cos to be the cos one because in the middle we had cos. In the second, in number 10, you change to be sine because in the middle we had sine. But here you have both because sine 2 theta is the same as 2 sine theta cos theta. Because now here you have both, then you'll change it to be the one of both. But now, at the same time, you'll have to create sine and cos because remember, if you have sine, in the middle you have sine and cos. If you have a constant, that cannot be factorized. So you have to get rid of the constant and creating sine and cos. It's like you did nothing here. If you say this 2 times cos squared plus sine squared, it's like we did nothing because cos squared plus sine squared is 1. 2 times 1 is still 2. So it's like we did nothing. So, but you only create if in the middle you have sine and cos and also have a constant. Then here, obviously, it will be 2 cos squared. When you add this, it will be 3 cos squared. Here it will be minus sine squared. Here is 2 sine squared. 2 sine squared minus sine squared is sine squared. In the middle, you still have minus 4 sine theta cos theta. Then you factorize. And like I said, if you have sine and cos, you divide by cos so that you have one ratio. So then divide by cos throughout. Then it will be tan theta equals to 3. Tan theta equals to 3, and then here tan theta equals to 1. We know that if we say shift, tan 3 will have 71,57 degrees plus k times 180 because the period of tan is 180. Here we say shift tan 1, that will be 45 degrees plus k times 180. Meaning that if you have a double angle of cos, check in the middle. If in the middle you have cos, you make it the cos one. If in the middle you have sine, you make it the sine one. If in the middle you have sine and cos, you make the one of both. Determine the general solution of tan theta minus sine 2 theta. Remember, whether it's identity or what, and you have sine and cos, tan make it a quotient identity. We know that tan is sine over cos. And then this is a double angle. It's 2 sine theta cos theta. Take sine as a common factor. He will remain with 1 over cos theta minus 2 cos theta. So for this one, sine will be 0. This 1 over cos theta will be 2 cos theta. Cross multiply. Then you'll have cos squared theta is equals to half. Then cos theta will be plus or minus the square root of half. Then you have theta will be plus or minus 45 degrees plus k times 360 because the period of cos is 360. Or you can say theta equals to 135 because remember I said plus or minus, and cos is negative in the second quadrant. Remember, plus 35 is in the second, and then minus 35 is in the third quadrant. So, and then in both the quadrants, cos is negative. So here you leave it like this. Now, number 13 in the diagram below, f of x equals to a sine a plus b plus g of x is equals to c cos d. By me looking, you can see that if a sine graph is start by going up, it means there's a positive cos, positive sine graph. So it means a will be positive 1. And then if you check again, we say x plus b. Now, we know that normally a sine graph must start from the origin. If it starts from minus 30, it means it has shifted 30 degrees to the left. And we know that if it shifted to the negatives, then your b will be a positive 30 degrees. And then C and D is for this graph. You can see that this graph has been compressed. Instead of passing at 90, it passes at 45. It means it has been is compressed. It means that your C will still be positive because this is a positive cos graph, but your x will not, your coefficient of x will not be 1 because the graph is compressed. You can see 45 is half of 90. Then it means there it is a cos 2x. Then d is equals to 2. Now, the amplitude of f and period of g. The amplitude of f is 1. Remember, even if the graph was negative, the amplitude is never negative. It will also be positive. And then the period of g, since the graph is compressed, the period will be 360 divided by 2. Then the period will be 1. Let me check. The period will be, here is 30. It means 30 is the third of 90. It means now the value of t will be 3, because now 3 times 30 is 90. So the amplitude will be 1, but the period will be 360 divided by the coefficient of x, which is 3 in this case. Then the answer will be 120 degrees. 1.13.3, the range of f of x minus 2. Remember, we say if the number is inside the bracket, is outside the bracket, it means it represents a vertical shift. So if we say f of x is minus 2, it means the graph shifted 2 units down. It's the range was between minus 1 and 1. It means if it shifts downwards, it means the range will be between minus 3 and minus 1. Because from 1, if you move 2 units downwards, it will be minus 1. From minus 1, if you move 2 units downwards, it will be negative 3. Therefore, the range of f will be minus 3 is less than y, and then also less than minus 1. And remember, in this kind of question, if you just say less than, and you are not saying less or equals to, you get it wrong, because minus 3 and minus 1 must be included. If h is obtained by reflecting g on x-axis and then translated 10 degrees to the left of h, the equation of h is, so we check, we said reflection on x-axis, it means y changes sign, then here it will be negative. Then we say plus 30, then it means when say 30 to the left, it means 30 to the negatives. Then you say where you see x, you'll put x plus 10. Then when you clear the brackets, it will be 2x plus 20 degrees. So one will be tempted to say 2x plus 10 degrees. No, you say 2 into, because you add 10 degrees not on 2x but on x. Cos A, B, coordinates of A, B, and C are, So here you do the general solution. We say sine x plus 30. Then we say sine 30 minus. So we make the ratios to be the same part. You check where sine is positive so that when you reverse it, it will be positive cos 3x. We change it to be a sine. That is why I put 90 degrees here. So we say minus 3x. Now, if the ratios are the same, therefore angles are equal, then we say x plus 30 equals to 90 minus 3x plus k times 360, where k is an element of integer. When you generalize it, it will be x is equals to 15 degrees plus k times 90. Now, to get the values, we'll just play with k. Oh, the other one, uh, cos sine is also positive in the second. Remember, 90 degrees plus 3x represent the second quadrant where sine is still positive. And then when you reverse it, it will be positive cos 3x. Now you have two things here, as I highlighted. Then it means for us to get the solutions, you'll just play with k. Then these are the values that you are going to get in this case. So obviously, if you check, if in that first one you let k to be minus 1, it will be minus 90 plus 15, it will be minus 75. The next one is when k is 0. 0 times 90 is a 0. Then we remain with 15 degrees. The last one is when k is 1 times 90 is 90. 90 plus 15 is 105. Then from there, if you get all these values, remember the values should be looking at the graph. You stop when you got all the values that they want. Now, if you can see, well, these are the correct values for A, B, and C. Now, to get the Y value, you can take these X values and substitute to one of the equations. You'll get the same answer. If you don't get the same answer, it means your X values are incorrect. The 18.6, for x is an element of minus 90 degrees and 0 degrees, the values of x for which root 3 sine x is greater than minus cos x plus 2 cos 2x. Now, in this kind of questions, they will give you something that will make you think they are giving you something new. They will rearrange the equations in such a way that when you look at them and try to fix, you'll see that the equations will still be the same. Like for instance here, if you take cos to the left, then it will be this. So then when you multiply, when you divide by 2, it will be root over 2, root 3 over 2, and 1 over 2. And root 3 over 2 is root 3 over 2 is a sine sine x, and so root 3 over 2 is cos root 3 over 2. Sorry, cos root 3 over 2 is cos 30, and then half is sine 30. Then you can see that it goes back to that equation of sine x plus 30 greater than cos 2x. Then you will check where this graph of sine is above cos 2x. So, and then if you check, look at the graph, remember we are saying between minus 90 and 0. You'll find that between minus 75 degrees and minus 30. Let's go back quickly there. Between minus 75 and minus 30, you can see that the sine graph is above the cos graph. So, but remember, it's not only there. If we're saying between minus 90 and 180, we'll also include the values in the first quadrant, but we only said between minus 90 and 0. Now, we go to, now here you are given in a diagram AB, you are given a diagram here, the values are there, you see that. The first one, determine the length, you want the length of CD. CD is the common side between two triangles. But now, remember, for you to apply trig ratios or any rule, sine rule or cosine rule, you need to know three values. So it means uh, this CD can only be calculated in ADC. The reason being that we're saying B, D, and C are in the same horizontal plane. So it means angle ADC is also 90 degrees. So it means we can use triangle ADC. Since it's a right angle triangle, remember we say it's 90 degrees because we are told that AD is the vertical tower and then B, D, and C are on the same horizontal plane. Then ADC is 90 degrees. If it's 90 degrees, then we use the triangle ADC. Then we'll say tan 50 degrees equals to CD over the given value there, which is 8. Then when you cross multiply, then C will be 9,53. 14.2, calculate the length of BD. Now BD is in different triangle. So BD, if you check, since we know DC, we see that we know the two sides with an included angle. We know that if we know two sides and included angle, the only rule that you can use to calculate here, it will be this cosine rule. Remember, for sine rule to be applied, there must be in one case where you know the angle and its the side opposite to it. Here it is not the case, so we must use the cosine rule. You use the cosine rule. So let's use the cosine rule. We'll say in triangle BCD, C squared. We start with C squared so that C will be the angle. That doesn't mean that we know angle C. C squared will be B squared plus D squared minus 2BD cos C, and C squared is BD, and then B squared is CD, which we calculated in number 1. Then it will be 9,53 squared, and then D squared is BC, which is 11. You substitute, then get the answer. You see that you put square root on the other side. Remember, C squared is the same as BD, and then angle C, we know it is 38. Then you get the answer here as 8,75 meters. 14.3, calculate the shortest distance from D to BC. The shortest distance is the height. So first, we'll use the area rule to calculate the area of triangle BCD. From there, when you calculate the shortest distance, here, we are calculating the distance from D to this side. It must be perpendicular. So now we know that if we have distance here, the area will be half base times height. Now the area, now we calculated it using the area rule. Now remember, shortest distance, it means what we are calculating is the height. So we first calculated the area using the area rule. From there, we say the area of a triangle is half base times height. If the shortest distance from D to BC, it means BC will be our base, and our base, we know it. In this case, let's check what the base is. We know that the base is 14. Then that's why we say 14. Then you cross multiply there. Then remember, half times 14 is 7. So then you divide by 7. Then the height, the shortest distance, which is the height, is 5,87. The size of ABD. Let's check the size of ABD. ABD, you can see that ABD, we talk about this size. Now, since we know BD and we also know AD, we can still use the ratio, which is tan. Then tan will be opposite over adjacent. Opposite is 8. Then adjacent is the BD, which we calculated. Then then it's 8,75. Then when you use the calculator, then you have ABD is equals to 42,44. Let us thank you so much for listening to this. I hope you found today's lesson very fit for the purpose of preparing yourself as you'll be sitting for maths paper in 2 weeks' time. Just want to wish you all the best. Fire all your cylinders until the last day. Thank you so much and keep on watching the videos.